So the next section in the textbook is about the periodic table. The periodic table is a tool that you will use in all your chemistry classes, essentially. It's a tabular arrangement of the elements in rows and columns, and it highlights the regular repetitions of the properties of the elements. It was independently determined both by Dmitry Mendeleev and Lothar Meyer in 1869, one working in Germany, the other one working in Russia. The video down here, which is on the resource page, kind of gives you how those periodic table came about, and the fact that most of these elements were missing at the time. The two things that we need to look at are period, which is here in purple. So a period is a row of the periodic table, and typically the periodic table goes from low molar mass to higher molar mass, which was originally how it was determined, but now it's by atomic number. Because there's a couple of exceptions. I believe nickel is one of them, in which nickel has actually got a higher molar mass than that of cobalt, but has more protons, now that we know a little bit more about it. So now nickel is in this column with palladium, and platinum. A group is an element of a column of periodic table. And this is important because of the fact that this dictates kind of the behavior of the elements. For example, in group 1A over here, or group 1 in the new form, lithium, sodium, potassium, rubidium, and cesium, all when exposed to water as pure metals, act as explosive. Now, the trend is that the higher up on the periodic table it is, the higher the row number, then the more explosive. So lithium is more explosive than sodium, sodium is more explosive than potassium, potassium is more explosive than rubidium, and cesium is the least of those, but it still has a violent reaction with water. So there are main groups, which in the U.S. means the group A. Okay, so I tend to think of that about this as a lopsided castle. Okay, where you have the turrets or the round part of the castle are the taller parts, and the body of the wall is the shorter part. Okay, it's just a lopsided castle. So the main groups are the taller sections. So in the new or in the old version, they're the A's. Okay, and then the B's are the transitions or the body of the elements. So transitions are B's, and this is US. And the reason that they went away from this system is because Europe has the opposite of this. Then you have the intertransition elements, which are the actinides and lanthanides. Those are down here. These are the ones that are featured down here on the periodic table. They would actually go over here, and all the transition elements would scoot to the right by 14 elements. So here's the lanthanides, and here's the actinides. You have alkali metals, which is an old name, and that means group 1A, and alkaline, which is group 2A. So the ones that are explosive with water are the alkalis. Alkaline is the 2As. Okay, so that's those. Group 7A is the halogens. And so on this periodic table, it's 17. So those are the halogens. And then I have noble gases, which is 8A or 18. Okay. Now, metals are typically a substance that has a luster or a shine. It's a good conductor of both heat and electricity. And here's some examples. I think this is copper and gold. And I can't read the rest of these right here. But they basically all shiny, and they are a good conductor of electricity and heat. A nonmetal is basically the opposite of that, which means that it tends to be kind of not no shine to it. It's a poor conductor of both heat and electricity. Examples of that are carbon, phosphorus, and sulfur. So those are examples of those. And then you have a small group called metalloids, which are semi-metals. Boron, silicon, germanium, arsenic, antimonium, and tellurium. Sometimes they act like a metal, sometimes they act like a nonmetal, and so they tend to be the ones that are used in semiconductor materials. Now, on this periodic table, before we get to the problem, the ones in purple are my metals, the ones in blue are the nonmetals, and the ones in green here are my metalloids. And so you see that by far I have many more metals than I do nonmetals or metalloids, but the two main groups are metals and nonmetals. Okay, so metalloids, yes, they're special, but basically we're going to treat them as either being a nonmetal or a metal from what we do in chemistry. So, number 58 in the book asks for the group and period of the following elements and if it's a metal or a nonmetal. The first one is palladium, which if I find my cursor, is right here, okay, element 23. So I can see that it's in group number 5B, and then the period, I come over and it's in period 4. So group 5B, period of 4, and since it's purple, it is a metal, and more specifically, a transition metal. The next one is rubidium. Rubidium is right here, element number 37. Okay, so it's in column 1A, or group 1A. It is in row 5, so its period is 5. And again, being purple, it is a metal. And it is a main group metal because it's in the taller part of the castle. The last one is iodine. Iodine is number 53 over here. Okay, so it's in group 7A. I come across, and the period is 5. And because it's in blue, it is a nonmetal. Okay. All right. Next question is number 60. It says, what is the element in 5A? Or which one's in 5A is a metal? Okay. So there's actually technically 2 choices here, but this is a new element. Okay, so we're not going to worry about that one. So the one that is not a new element is bismuth. Okay. Second one asks to know what is the element in group 2A and period 2. So here's 2A and here's 2. So Be stands for beryllium. And that is the end of this section.